Okay, welcome to class, guys. I'm gonna continue with chapter 6. Okay, the production, even it's in the final part. So final only covers chapter 3, 4, and 5, okay, which is about consumer. Yes. Oh, the TV. Why? Let's see. I can't raise that. You sit here. Sit here. In line. Okay. Have I told you before, there are 3 exchange students from China, but I think they're gonna be here maybe in the middle of this month. So they just come here and take the exam. Okay. For the recording, even only 6 reviews, but it doesn't matter. If you don't understand, you can review it later. So today I'm gonna continue with my teaching, okay? I finished 6.1, so which is firms and their production decision, right? And next one, 6.2, production with one variable input. So here we consider owning labor. And next section, production with 2 variable inputs. If you want to produce something, basically you need labor and capital, right? So we're gonna talk those 2 kinds of inputs in order to produce something. And later, we're gonna talk about returns to scale. So please go to page 13. Right, next section, production with 2 variable inputs. So here you need to know a new terminology, which is isoquant. What is isoquants? Isoquants curve showing all possible combinations of inputs that yield the same output. How does it look like? Look at this one. This is the isoquant, right? Q1, Q2, and Q3. Can you think about the curve that is in consumer side, which is similar to the isoquant? Chapter 3, consumer behavior, right? We have indifference curve. Indifference curve also looks like this, right? But here we talk about production. So right now you are not a consumer anymore. You need to flip side. You are a producer. You care about the production. Okay, so let's start with the definition. So you need to know the same product. Okay, it's the combination of inputs that yields the same output. So basically this section, both labor and the capital can change. Okay, so here we're talking about labor and capital. This is more realistic, right? In the reality, you can change both of them. Okay, isoquant, let me explain it to you in plain words, which means that it's a curve showing all the different combinations of labor and capital that give you the same output. Okay, so I highlighted output here. Look at table 6.4. You see, Please find the circled 75. How many of them? We have 1, 2, 3, 4. Let's see the combination. So output equals 75 happens at 4 different combinations, right? The first one, this is the capital input. This is labor input. So the first case, 1 capital, 5 labor, right? Second case, 2 capital, 3 labors. The third case, 3 capital, but only 2 labors. The last case, we're gonna use 5 capital, but 1 labor, right? So you see here, different mixes of inputs, but same total output, right? The output is fixed, which is 75. Why does this matter? Why does this matter? Because it shows firm has flexibility. You can produce the same amount using more machines and fewer workers, or more workers and fewer machines, right? An isoquant is just the line connecting all these equal output combinations, which is here. Okay, this is isoquant. This is another one, and this is the third one. And next point, so what is isoquant maps? It's just several isoquants joined together on one graph. Okay, that's why we have the maps. Like a topographical map, but instead of showing equal elevation, each line shows equal output. Okay, of course, higher isoquants, which is further from origin, equals more output. Okay, higher isoquants means more output. Same as indifference curve, right? Indifference curve, higher indifference curve, more utility, more satisfaction. Okay, let's look at this figure, figure 6.5. This graph shows an isoquant map. Okay, this is the isoquant map. Why? Because we have 3 isoquants, right? Q1 equal 55, Q2 equal 75, and Q3 equal 90. Moving to a higher isoquant, which means further from origin, means more output. Okay, let's take a look at points A and D. You see points A and D, they are both on Q1, which is 55 units of output, right? But point A, 3 capital with 1 labor, but point D, 1 capital with 3 labors. Just different combinations of inputs, right? But along the same isoquant, the output is the same. Okay, same for B at Q2 and C and E on Q3. And right now, let's draw a horizontal line at capital equal 3. Okay, this is the horizontal line. And look at here. So basically, at this point, capital stays fixed, which means K equal 3, right? Capital, we use K to represent. Labor, we use L. Okay, so let's take a look at this point. At K equal 3, which means capital stays fixed. And we only increase labor here, okay? At point A, we use 1 labor. Point B, we use 2 units of labor. Point C, we use 3 units of labor, right? And you see the output from 55 to 75 and then to 90. Let's see the increase from A to B, the output increased. How many of output increased? You use 75 minus 55, right? So which is 20, right? And from B to C, how many output increased? You use 90 minus 75, which is 15. You see here? This is why, okay, you see 20 and then 15. This is why we see diminishing marginal returns here. Okay, this is the sign shows that diminishing marginal returns with capital fixed. Each extra unit of labor adds less additional output than the previous one. Exactly the same pattern we saw back in table 6.1. You still remember table 6.1? Here, right here I showed you we have diminishing marginal product, right, in this table. And then here I showed you diminishing marginal returns. Same as consumer behavior, diminishing marginal utility, right? So basically, the logic is the same, just different stories. Okay, let's move on. Here we have two ideas. The first one, input flexibility. What does it mean? Isoquant shows the flexibility that firms have when making production decision, right? Because different combination they can choose. They can usually obtain a particular output by substituting one input for another. It's important for managers to understand the nature of this flexibility. Okay, because at this, let's see the Q1, they can produce here, and they can produce at point D. No matter which point they choose, will give them same output, which is Q1 equal 55. The next one, diminishing marginal returns, I just mentioned to you. Okay, if we hold capital fixed, we add labor, which means we have diminishing returns to labor, which is I showed you here. Okay, this is diminishing marginal returns to labor. Because here we are increasing the labor here, right? The same idea, if we fix the labor, if we hold labor fixed, add capital, which means we have diminishing returns to capital too. So let me highlight it here. Diminishing marginal returns to capital. So both cases, we're going to have diminishing marginal returns to labor and capital. This is why isoquant curves the way they do. Steep at first, let's see here. Steep, okay? Look at the slope, steep first, and then flatten. Steep, okay, move along the curve and flatten, right? As you swap labor for capital along an isoquant, each unit of capital added contributes less and less. So you need more and more capital to make up for one less unit of labor. Hence, the bending curved shape. Okay, so we have new concept. Actually, it's not new. In consumer behavior, we learned marginal rate of substitution, right? But here is marginal rate of technical substitution, in short, which is MRTS, all right? So this is amount by which the quantity of one input can be reduced when one extra unit of another input is used so that output remains constant. What does it mean? Okay, so marginal rate, it sounds complicated, but it just means if you use one more unit of labor, how much capital can you give up while keeping output exactly the same? Basically, MRTS is just the slope of the isoquant. Well, okay, we always like to talk about the slope, all right? So the amount of capital you can give up for one more worker gets smaller and smaller. This is why isoquant curve inwards, which is convex to the origin. The same shape logic as indifference curve back in chapter 3. Okay, you see the equation here, MRTS equal change in capital input over change in labor input. This is the general idea of a slope term, right? The change in Y over change in X. But in our case, where is our Y? The Y-axis is the capital. But the X-axis is the labor, right? That's why you have delta K over delta L, right? And then diminishing MRTS, what does it mean? Just like the amount of capital you can give up for one more worker gets smaller and smaller. Okay, I'll show you how we get this formula, 6.2. You see, marginal product of L over marginal product of K equal the delta K over delta L, which equal MRTS. How does it come from? Where does it come from? Okay, one more point. Let me emphasize. At the same isoquant curve, the output remains constant. Is that true? Yes, because you see, at Q1, the output is the same, which is 55. It doesn't change, it's the same, right? So let's derive. Let's derive 6.2. Start with the idea. Along the same isoquant, output Q is held constant. Okay, ISOQ means isoquant. Output Q is held constant. That's the definition of an isoquant. The first step, what is the total change in output? Okay, so that's why it's here. if labor changes by delta L and capital changes by delta K, the resulting change in output has two parts, right? Because we have both the change from the labor and also the change from the capital. Okay, so we have two parts. The first part is the extra output from the change in labor. This is the first part, which is the marginal product of labor times delta L, right? The marginal product of labor times the change in labor. This is the first part. And because here we are talking about two inputs, right? So the next extra output from the capital, right? From the change in capital. The same idea, which is marginal product of K times the change in K. So this is the total change. Okay, this is the total change. So let's write down the total change, which is delta Q, which is the total output change, equal MPL times delta L plus marginal product from capital times delta capital. Right? And here, the output remains constant, which means the total change of output equals 0, right? The total change. So here is 0. The idea is that because we are moving along the same isoquant, output doesn't change at all. That's why we have delta Q equal 0. Okay, so I replaced 0 here. And next one. Okay, this is the step 2. Next step. Let's isolate the capital term. What does it mean? So right now, I'm gonna move the labor term to the other side of the equation, okay? So what we have, so let's write down the capital term first, MPK times delta K equal, okay? We move the labor term to the left side, to the right side, which means it becomes negative, right? Because here is positive. If we move to the other side, it becomes negative. Right, so here I just isolate the key capital term, and then we solve for delta K over delta L. First of all, we divide both sides by MPK. What do you have? Let me copy this one. Okay, so let's divide. Let's divide both sides by MPK. Okay, so basically we can cancel out here, right? This is 1. And next one, let's divide both sides by delta L. So the left side will only have delta K here, right? Equal remember we divided by delta L. So we can cancel this term as well, right? This is 1. So what do we have here? This is the term that we have. Okay, so you see delta K over delta L equal marginal product of L over marginal product of K, which is same here, right? It's just the idea is like y equal kx plus b. We want to isolate the y term, but in our graph, which one is the y term? Delta k, right? Delta k is the y term. So this is our marginal rate of technical substitution. Okay, the intuition is that MRTS is the ratio of marginal products. If labor's marginal product is much higher than capital, one more worker is worth a lot of capital, right? So we can give up a lot of capital for that one worker. That's exactly why MRTS equal marginal product of L over marginal product of K, okay? It's comparing how productive each input is at the margin. Okay, so here I showed you the derivation of equation 6.2, okay? Next one. Okay, so this graph shows exactly what diminishing MRTS looks like in numbers, okay? As I mentioned before, just like our indifference curve, isoquants are downward sloping and convex. All right, so let's see here at the isoquant, which is Q2 equals 75. Okay, let's take this as an example. You see, this is delta L equal 1, which means one more additional labor, right? One more additional labor. Okay, so for basically we are talking about the slope here. For one more additional labor, at this point, how much capital we are willing to give up? 2 units, right? You see here 2 units. Okay, from 5 to 3. So at this point, we are willing to give up 2 capital. And let's move on. How about this point? We are willing to give up just one, because from 3 to 2, right? And let's move around. At this point, we are only willing to give up 2 over 3. Can you see it? This is here, okay? 2 over 3 of capital we are willing to give up for one more extra labor. And here, if we move to the end of the isoquant, you see here, this is 1 over 3. So basically, at this point, we are willing to give up 1 over 3 capital in order to get one more labor, right? This is the slope of the isoquant of Q2. Okay, steep first and then flatten, right? That's why we have our MRTS, okay? So you see, on isoquant Q2, the MRTS falls from 2 to 1 to 2 over 3 to 1 over 3. This is diminishing MRTS, okay? This is diminishing MRTS. Why is that? Why is that? Okay, so at first, you are at this point, right? At this point, you have lots of capital and a little labor, right? Because you have 5 capital but 1 labor. So 1 worker is very valuable for you, worth giving up a lot of capital for, right? But as you keep adding worker, okay, move along the curve, labor becomes more abundant. Let's see this point. You have 4 labor, but only maybe 1.5 capital, right? Labor becomes more abundant and less special. That's why you just want to give up a little of capital to 1 more unit of labor. Okay, so you need to remember that isoquant is convex, just like our indifference curve, okay? Convex. The same diminishing returns logic we've seen throughout this chapter, now just applied to substitution between 2 inputs, capital at y-axis, labor at x-axis, right? So this graph is the visualize of diminishing MRTS. Next one, 2 extreme spatial case production function. The first one, perfect substitutes. Have you heard this one before? Perfect substitutes. Right? When we learn consumer behavior, if the 2 goods are perfect substitutes, what is their indifference curve look like? It's a straight line, right? Okay, so let's see here. The first one, perfect substitutes. Okay, this is the first case. And then we have fixed proportions production function. So we have 2 spatial cases, all right? Perfect substitutes, which means inputs can freely replace each other at a constant rate. I'll show you the graph later. Okay, so remember the constant rate. But for fixed proportions production, we also call it liangtive. In Chinese, 里昂替夫. How about in Thai? How you call it? 那是啥 Thai? How you pronounce this one? Liangtive. I just said in Chinese we call it 里昂替夫, which is just direct translation from English. How about Thai? Have you heard about this one? No? Okay, how are you gonna pronounce? Maybe the same. Okay, so for fixed proportions production function, it's Leontief production function, right? What does it mean? The isoquant is L-shaped. This means only one combination of labor and capital can produce a given output. No substitution is possible at all. Okay? So here L-shaped, which means this production method is rigid. It's not flexible, which means rigid. You must use inputs in a fixed ratio, okay? Fixed ratio, no flexibility. Think about the example of Leontief production function. One taxi needs exactly one driver, right? So one taxi needs exactly one driver. You can't substitute more drivers for fewer cars or more cars for fewer drivers. Okay, this is an example for Leontief production function. Okay, so here, this graph shows you what perfect substitutes look like on a graph. So the isoquant is a straight line, right? The isoquant is a straight line. If the isoquant is a straight line, what does it mean? So the MRTS is changeable or constant? Constant, right? Because it's a straight line. At point A, B, C, they have the same slope, right? So this MRTS is constant. The same trade-off rate between capital and labor at any point. Okay, let me give you one more example, or can you think about one production method is perfect substitutes? Okay, think about the food store at Langmo. Actually, the seller, they can use a gas stove or electric stove, right? So gas stove and electric stove work equally well, so they are perfectly substitutes. Let me write it down. Okay, so they are perfectly substitutes. So next one, Leontief production function. The first one, L-shaped, right? L-shaped. Look at point A. To produce Q1, you need exactly K1 and L1. No other combination works. Adding more labor alone, you still get Q1, right? And adding more capital alone, moving up from A, doesn't help either. So the vertical line stays flat. So we have the vertical part and the horizontal part, which is L-shaped. The only way to produce more output is to increase both inputs together, you see, from A to B. At point B, we need L2 units of labor and K2 units of capital, right? So the same fixed ratio, okay, the same fixed ratio. Moving from A to B to C along the diagonal dashed line, okay, which is the same fixed ratio. The example that I just told you, taxi driver, taxi and one driver, okay? So for a taxi, we need one driver and one vehicle. We need both together. We need both together in fixed proportion. That's why it also called fixed proportion production function, all right? Fixed ratio. Fixed ratio of inputs. Next one, next topic, returns to scale. New words for you. And this is the last section of this chapter. And let me emphasize, this is about the long run. Okay, which means every inputs are variable. We can change every inputs with both labor and capital increase together proportionally, just like doubling everything at once. So let's see the definition. What is return to scale? Rate at which output increases as input are increased proportionally. All right. So return to scale asks, if I double all my inputs, does output double too? More or less? More than double or less than double? So we have three cases here. The first one, increasing return to scale. Okay, in short, I'm going to show you the short term. So for increasing return to scale, which means we doubled our inputs, but output more than doubles, okay? For constant return to scale, which means we doubled our inputs, output exactly doubled. Okay, the last case, decreasing return to scale, which means we double our inputs, output less than double. Right, so we have three cases. Those two graphs shows you. Okay, look at A. This graph shows how to spot returns to scale visually by looking at the spacing between isoquants along a straight line OA. Okay, so you need to look at this diagonal, which is OA here. Let's look at the first case. Can you tell me this A is increasing or constant or decreasing? Okay, you see here, this is Q1 equal 10, this is Q2 equal 20. In order to get Q1 to Q2, right, you see our inputs from 5 to 10. Doubled, right, input, doubled. How about our capital from 2 to 4, which is double as well? I'm gonna use 2, okay, this is double. Labor is double, capital is double. How about our output? From 10 to 20, which is double as well. And then from Q1 to Q3, we need triple both inputs, right? You see, from 5 to 15, triples, right? Same here for capital, triples. But our output triples as well. So this is constant return to scale, right? Constant return to scale. Okay, CRTS, which means constant return to scale. And another thing is that you see the isoquants, they are equally spaced from Q1 to Q2 to Q3, right? They are equally spaced. Okay, so let me highlight here. So equally spaced is constant return to scale. Let's look at B. From Q1 to Q2 to Q3, our inputs doubled, but how about our outputs? Less than double, right? Less than double. From 10 to 20, less than double. And from 10 to 30, less than triple. And also, the isoquants get closer together. So what is this case? Increasing or decreasing? Increasing? Yes, exactly. So if you see that the isoquant moves closer together, this is increasing return to scale. All right. So the summary is equally spaced isoquant along a ray. This is the ray, okay? This is OA, this is ray, RAY. Along the ray, if it's equally spaced, it's constant return. If the isoquant gets closer together, it's increasing, right? So this is just the summary of I just mentioned. Okay, constant return to scale for A and increasing return to scale, okay, for B. What is the key point in this slide? The key point is that return to scale vary considerably across firms and industrials. What does it mean? So the key information for this slide is a firm's return to scale don't have to be the same at every output level. Okay, they can be varied, which means not the same, okay? Don't have to be the same. What does it mean? A firm might have increasing return to scale at small scale, constant returns in the middle, and decreasing returns if it gets too big, right? And in general, industrials with greater returns to scale tend to have larger firms because bigger scale is more efficient there, right? Okay, be careful. Return to scale don't have to be the same at every output level. Okay, let's practice this one. Can you tell me, is it in constant return to scale or increasing or decreasing? I'll give you 3 minutes. Okay, from this table, is this production increasing, constant, or decreasing return to scale? You check about the input. Okay, capital and the labor, they are inputs here and outputs. So you see, if you double your inputs, how about your output? If it's the same, which means constant. If output doubles more than double, so increasing. If outputs less than double, which is decreasing, I'll give you 3 minutes. Okay, so can you tell me what kind of production is this? Decreasing. Okay, decreasing. You guys have the same answer? Decreasing. Why? Okay, let's see. You see capital. Capital from 1 to 2. Did capital double? Did capital double? Yes. Right, capital doubled from 1 to 2. So we doubled our capital. How about labor? Did labor double? Exactly, right, from 5 to 10. So doubled labor. How about our output from 20 to 30? This just 1.5, right? You see here, we doubled our inputs, but our output only increased 1.5 times, which is less than double, right? So this case, so actually the output grew by only 50%, right? So this is decreasing return to scale. Okay, so I think I'm gonna finish it today, but I don't finish the class. I still have 1, 2, 3, 4 slides. I'll send you the recording because right now we're gonna have the quiz. Okay, so for the rest 4 slides, I'm gonna send you a recording. You will watch it before you have the midterm exam. So this quiz is about chapter 5. Oh, I need to share my computer. Okay, so better for you to review, right? No, stop sharing. Okay, so please join the Kahoot. Same as before, you're gonna get extra points if you get the top 3. And for your for your midterm exam, we have both multiple choice question and short answer question. Okay. So for multiple choice question, it's similar to the Kahoot, but for short answer question, it's similar to your exam. You must know how to do the Lagrangian, the first one, and then you need to draw the graph for maybe normal good, inferior good, and given good. I just pick one of them. Okay, it's in chapter 4, right? How to draw the Marshalling demand and Hixing demand. So I already emphasized you 2 knowledge that I'm gonna test you. Okay, we have 28 attending here. It's about chapter 5, okay? Uncertainty and expected utility. 26, one more, two more, I think. Or I'm gonna start. Everybody is in Kahoot. Everybody is in Kahoot. Okay, I'm gonna start. Why I have 27 here, but 28 for the attendance? We have 15 questions. Which of the following best defines the expected value of an uncertain outcome? If you cannot see, you can move closer. It's the probability weighted average of the payoffs with all possible outcomes. What is the expected value of this game? You use 0.4 times 100 plus 0.6 times 40. Standard deviation. Higher standard deviation, more risk. Okay, standard deviation. Risk averse. Risk averse because they prefer a certain income to a risky income. They don't like risk. Yes, for risk averse, their utility of income curve is concave. Okay, it's concave, reflecting diminishing marginal utility of income. So this is a quadratic function, right? What does this mean? I squared quadratic function, it looks like this, which is convex. Convex means risk loving, right? Because we just talk about concave, which is risk averse. So convex is for risk loving. What is the risk premium? It's the maximum amount of money a risk-averse person will pay to avoid the risk. In difference curve, this is standard deviation. Steeper. Because the degree of risk aversion increases, okay? What is actually fair for insurance? Actuarial fair means the insurance premium is equal to the expected value of the payoff. We'll talk about this one because of what? Diminishing marginal return. Yes, we have this one. But for an insurance company to make a profit, because of the law of large numbers, they can predict the average. Reduces income risk. What should the farmer do? Diversification. Just plant both. Diversification. Risk neutral pricing. Two assets held in a portfolio are perfectly positively correlated. Combining them will increase risk above that of holding either assets alone. So it provides no risk reduction benefit, right? Because they are perfectly positively connected. So they move together. How we calculate the value of complete information? So this is the expected value, EV means. So it's the difference between the expected value with complete information minus the expected value under uncertainty, right? Which is incomplete information. Last two questions. What is risk neutral? Indifferent. Indifferent between a certain payoff and a risky payoff. Last question. Expected income, okay? This is the expected income. This is the standard deviation. One is 2,000, another one is 10,000. So a risk-averse worker will choose which one? Right, prefer job A because it offers the same expected income with lower risk. Let's see. G, top 2, PKK, and then top 1, PK, right? Okay. Thanks for coming. If you don't have questions, so I'll see you on Thursday. And for those who got top 3, please come and tell me your student ID, since you'll get the extra point.